Hi class, we're going to be taking a look at a property that's needed for fractions. And this is the idea of prime factorization. So the following problems have a couple of actual instructions. They want us to provide the tree and then express your answer as exponents and factors. So let me actually do this one by example. So here's the idea on the prime factor tree. So all numbers are composed of primes, and prime numbers are numbers that are divisible by technically one in themselves greater than one. So you basically start the prime factor tree in this form. So you're going to start with a value of 24, which is the number that it's given. And then this 24 can be broken up into two factors. This will be 2 and 12. And the idea is, as you're breaking up the number that you're given, you're basically selecting the primes. In this case, 2 is prime. 12 is not. 12 is composite, which means that it's basically composed of primes. And then 12 can be expressed as 2 and 6. And then we actually have another prime. And the values of 6 happens to be expressed as 2 and 3. And here we have 2 more primes. So another 2 and another 3. This is your, well, technically the prime factor tree. Your actual answer, you're going to express it as follows. So the values of 24 in terms of factors, and factors means numbers that multiply to 24, you could express it as, and then I'm just going to be selecting the primes. So technically this will be 2 times 2 times 2 times 3. So this is your solution as factors. And let me just write it as. And then as exponents, well, you can express, well, there's 3 2's. So this is 2 to the third times the values of 3. That would be another way to express the solution. That's actually it for this given problem. Let's take a look at the next one. In this case, we're given the number of 15, and this one's going to be an easier one. So you have the values of 15, and 15 can be broken up into, well, technically 3 times 5. This one took just one step. Here's your prime factor tree. Then your actual answer, we would just say that 15 as the product of primes, it's going to be 3 times 5. No exponents because we technically just have the exponent of 1. There's no values that you multiply more than once. So at this point, that's actually it. And notice that on these two answers, we're not using 1. That's because as we're looking at the set of primes, you're looking at only numbers that are greater than the values of 1, so not including 1. Let's take a look at problem 3. In problem 3, we happen to have 100. And on 100, you can break it down into 2 and 50, 2 being prime. And then the values of 50, you can break it down into 2 and 25. Once again, here 2 is prime. And notice that I'm only boxing in the primes. And then 25, well, 25 happens to be 5 and 5. So let me box in my answers. In this case, both of the 5s. And keep in mind that what we're doing here is expressing the numbers as multiplications. So technically 100 is the same as, well, 2 times 2 times 5 times 5. This is as factors. Or you could also express the number as 2 to the second times 5 to the second. That's with exponents. So the solutions are asking for all 3 forms. Also, here's the prime factor tree as part of our solution, and you just have to be careful on these problems that you're only selecting the primes, so you're not circling the 25 because 25 is technically composite. It's you can express it as a product of primes. That's actually it for this set of problems.